The Aspen Center for Physics is a national treasure. Indeed, it is designated as one of the historical sites of the American Physical Society, which calls us a premier summer home for theoretical physicists worldwide. Some of the most important discoveries in physics over the past 60 years were made here in Aspen, and some of the speakers may touch on those. The center is not associated to any university, but is run by a group of physicists and friends volunteering their time. It is a miracle that a place like this exists and is thriving. I came to the center for the first time in 1989 when I was moving from the Institute for Advanced Study in Princeton to my first faculty appointment at the University of Chicago. I fell in love in this place, and I've been here for almost every summer for the last 30 plus years. Today, we have assembled a wonderful group of speakers who will tell us about the past, the present, and the future of the center. Since the schedule is tight, and I'm supposed to be the timekeeper, so let's move on. Let me start now. The first speaker is Randy Durand, Professor Emeritus at the University of Wisconsin-Madison. He was the president of ACP in 70s and is currently an honorary trustee, and he's going to tell us about the founding of the center. Randy, please, here is your microphone.
Well, the Physics Center had a very interesting beginning. George Stranahan, who was one of the principal founders, had been acquainted with Aspen for many years, skiing and being here in the summer. He was, in the late 50s, a graduate student at Carnegie Tech, now Carnegie Mellon University, in theoretical physics. He thought it would be wonderful to come out to Aspen in the summer, work on his dissertation research here, and enjoy the mountains when he wasn't working. So he came out, rented a house for the summer, and started to work. This went on for a couple of years. But he found very soon that he couldn't make much progress in his dissertation work because, as he said, I need somebody to talk to. Theoretical physics involves a lot of talking about new ideas, about progress, and just general exchange among the physicists involved. At the same...
Randy, excuse me, it seems like the program with the speakers in Zoom. Is this something we can...
And we're trying to fix it. Can we pause for just 1 minute?
What?
Yeah, they're going to look into the program just 1 minute.
Okay, fine.
Yeah, please excuse us. There are people who are connected over Zoom from other places. And we want to make sure they can hear us.
All right. George Stranahan was out here working on his dissertation research when he realized he needed somebody to talk to. He couldn't make progress without conversations about ideas and methods. At the same time, Robert Craig, who was then the executive director of the Aspen Institute and had a background in biology, was thinking about adding science to the Institute's programs. They were purely humanistic at that point, and he felt in the modern world some science was necessary for a well-rounded program. The program then was much different from what it is now. A local architect, Sam Caudill, who knew both of them and had heard from them about their ideas, invited them to dinner. They talked and decided, yes, it'd be a very good idea to have a summer research institute here and bring some physicists in who could then participate at least peripherally in the Institute's programs. So they decided to pursue that idea. George went back to Carnegie Tech and talked to a professor there, Michel Béranger, who he had known for some time, and Beranger thought it was a great idea. He was a person very interested in being in the mountains, and this appealed to him as a great idea. He knew somebody else who was interested in the mountains and was at the same time interested in starting a summer research activity in the mountains. That was Michael Cohen, the University of Pennsylvania. He had been at Los Alamos many summers and had thought it'd be a good idea to get a group of physicists together, have them camp out in an area near Los Alamos and talk about physics. That's not a very practical idea, but it was an idea nonetheless. Beranger knew them both and thought they should get together and arranged a meeting at Pittsburgh Airport with George, Bob Craig, and Michael Cohen. They hit it off immediately on the ideas and set to work making this come true. George was in charge of fundraising in Aspen and getting a building for the center. Michael Cohen was in charge of getting a group of eminent physicists to agree to be an advisory board so the place would be taken seriously, and to rounding up a number of very active people for the first summer program. And Bob Craig, who had lots of Washington connections from his work at the Institute and lots of foundation connections, was to pursue those connections and try to raise us some funds for the program. Well, everything worked. Craig managed to round up some funding. The Office of Naval Research agreed to support the program for a couple of years. Mike Cohen assembled the distinguished board so nobody could look down on this as some kind of boondoggle. And George was here in Aspen raising funds locally as best he could, and then funding himself the construction of the first building, now called Stranahan Hall. So that's how we got started. Now, first summer, 1962, I was out here on the first day. The building wasn't yet finished. We had offices over in the meadows for a couple of weeks, but then things settled down. We had a very successful program. And it went on from there. The first few years were mainly developmental, lots of important work going on, lots of conversations among physicists, and we were beginning to be taken seriously. A big step came in 1968. In 1967, Bob Wilson, who was the director of what became Fermilab, then the National Accelerator Laboratory, spent a summer here and decided this would be an ideal place to have a summer study for the big accelerator they were building. They needed physicists to discuss the experiments to be done and the facilities which would be needed to do it. And they thought this would be a good place away from the usual distractions of home institutions. He proposed to George that they have a summer study here. George talked to me. As it happened, I was on the NAL advisory board. I thought it was a great idea. In a meeting of the board, we discussed it and approved it. George approved it and decided to go ahead. George, in the spring of 1968, arranged the construction of a new, basically just bare wooden shack, which became known as Hilbert Hall, as a temporary building. The temporary building lasted until 1995. Well, at the same time, the Aspen Institute decided we didn't really fit into their program, so they asked us to become an independent corporation. We incorporated in 1968. So we were separate on the Institute property, but completely independent. The summer study went extremely well. 1968 and 69 greatly increased our exposure nationally, brought many more people here, and well, it was altogether a very good thing to do. After the summer study was over, 1970, we took over that building and could increase the number of people we have coming here. The first summer, there were only 42 physicists here in the entire summer. That is about half of what we now have in a typical week during the summer. So it's been quite a change. We took over the building, began to increase the participation, added new areas or increased ones that we'd had limited participation, condensed matter physics, astrophysics, et cetera, and gradually increased the number of participants. We got, finally, after many years of trying, funding from the National Science Foundation. First year, 1972, a grand total of $33,000. That's funding has continued until today, but funding has always been something of a problem. In the early days, it was touch and go from year to year. George kindly covered overruns in our budget for the first few years and made sure we continued to exist, we'll put it that way. In the early 70s, we decided we needed another permanent building because we still did not have enough space. We managed to raise funds from Fleischman Foundation, Kresge Foundation, and built the building, Beta Hall, back in the back of the campus. That was named for Hans Bethe, an eminent physicist, Nobel Prize winner for his work on understanding how stars work. He contributed part of his Nobel Prize money to the center, which went partly into the building Beta Hall. Everything was going very well. The center was thriving, expanding in various areas, and I think I will leave the description of what was going on to the next speaker. I was president from 72 to 76, and that's a good place for me to stop the activities through 76. Thank you. George wanted a place where physicists could talk. Do they talk? Well, you can wander the halls and hear them. But perhaps the best summary was when my wife did the oral history of the Physics Center in the 1990s. She had the insight to ask the kids of physicists what they thought their parents did at the Physics Center. Among the answers was the one which stood out. One of the sons said, "They don't work, they just talk." George was successful.
Thank you. So the next, Patrick Stranahan, George's son, will remembering his George's story. Thank you. Please. Here's a microphone for you.
Thank you. Just have a few gigabytes of notes here to refer to. I'm sorry. I look around and I don't feel underdressed because, to my recollection, I never saw a jacket or a tie anywhere in the Physics Center. Not these, the conventional groves of academe, from which many hailed. They were able to leave their jackets behind. So these are the reminiscences of a child and of a layperson. My memories of the origin stories of the Center for Physics, they're not scientific, so possibly not accurate either. My formative years and those of the center coincided. I'm dating myself, my birthday preceded the center's by half a dozen years, but we shared the same sire. This was the place my dad, George, came to work every day and returned up the narrow, precipitous, red dirt Upper Woody Creek Road at night in his open Jeep. The whole history and somewhat Byzantine evolution of the institution is wonderfully detailed by Jeremy Bernstein, who mentions the leisure of the theory class. This was a lucky experiment, proved out by what Dad called building the road by walking on it. Looking around now, cross-pollination of ideas in a dedicated environment that happens to be in a beautiful place has apparently worked. So the loci of my childhood memories are of our cabin up in the mountains and the lush and verdant setting of the physics center. We children were regular visitors, tolerated underfoot amongst giants, adults, that is, who we knew as often amusing and pleasant folk, and who we came to realize were each towers of intellect. Some of them even towered above the rest. The collegiality of these minds was often in play, and impressions of valuable, if incomprehensible, discussion remain in my mind. But the talk was not all science, because most everyone had pursuits and pleasures in the summer Rockies, and these were shared. Mountains were climbed and rivers fished, trails trodden. Earnest discussion took place in front of the topographic map wall, as well as the chalkboards, which I was pleased to see are still chalk and are still black. So I'm glad that that memory has stayed fixed in a physical sense. So I remember Michael Cohen taking us boys up climbing at Independence in jeans and Keds. And I remember the motivating discomfort of falling on a single bowline loop around the waist. I don't recommend it. The smell and feel of that terrific granite, and Michael's mentorship, and mostly his tremendous joy in climbing. Any rock, it might be a fireplace or a rock foundation. He was a wonderful friend of my brother Mark and I, and our dad. Well, as the 60s lunged along, I remember my dad, George, going a number of times over to a grand jury in Denver that was investigating the actions of the town burghers and some primeval local law enforcement that were bent on stymieing the first infiltrations of hippiedom. Apparently, some physicists were targeted for walking around with subversive beards, for wearing sandals with socks, some for having foreign accents, and other attributes confused with this brand new Aquarian culture, which was soon to become a full invasion, first in Aspen and then the world. These injustices against the physics community had to be confronted, and so he went. As a child, the weekly picnics are a continuous memory. I hope you all still have those. Heaps of food and tubs of beer, jugs of Almaden wine. Also not recommended. One clear memory I have is of Frieman organizing foot races among the children, which he ran backwards and won and turned into a physics lesson. I don't think he was cheating, really. Is that fair handicap? Another memory, my hostessing mother cherished the belief that corn on the cob should be buttered with an implement, for manners and hygiene both, a belief she maintained with us children. One physicist didn't share this precept. Mark and I stood by as he approached the table and pointedly slurried his ear of corn through the butter stick, back and forth, and pointedly remarked that this was the true and salubrious way to apply the condiment, and walked off satisfied. My mother had no remonstrance. That physicist was Randy Durand. But these were gods with title to caprice. I can use either method today, a benefit of community education. Thank you, Randy. At the end of these evenings, we would ride back from whichever picnic ground, huddled in the chill in the open Jeep, my father still in shirt sleeves, the star-littered Colorado sky up above. The center had and has blackboards. And these might fill up with equations. I see they still do. Nature hates a vacuum. And theorems, and there might be much discussion and talk. I remember the talk, walking in the halls and hearing conversations that were utterly incomprehensible to a child of only humanistic nature. Eventually there would be a repletion to the chalkboard, and the monument would stand, patterns of chalk, like an insect's wing or the back of a trout. It might as well have been Greek to me, because it was. Then I would be favored to erase the board and wash it to receive the next evolution of this community of thought. And then I would take the erasers out and purge their burden of chalk in a form of closure, slapping them together so that the white particulates of genius drifted free and settled on the rich green grass of the Center for Physics, which they might still nourish today. Thank you.
Service Professor Emeritus at the University of Chicago. He was the president of Aspen Center for Physics from 1989 to 93, and then the chair of the Board of Trustees to 2009 to 12, and currently is an honorary member. And he's going to talk about the story, and this time, the center matures. Please.
Thank you, Hiroshi. And it's a pleasure to have that mask off. I guess it's almost 75 years ago that Walter Paepcke proclaimed the Aspen ideal of lifting us out of our usual lives. And for the past 60 years, the Physics Center has enabled physicists to do just that. And so I've been asked to talk about this period from 1975 to 2000, where the Physics Center really came of age. And I've chosen to include a lot of pictures, and these are pictures that were taken by Bernice Durand, who was the first female trustee of the center, and they're absolutely wonderful. They capture, here's one of Randy, Paul Fishbane, I think was the third president. She captured me in 1984. Not material for chairman of the board. Mike Simmons, who I saw here earlier, one of the early presidents, and of course Sally Mensimer, our first administrative vice president. So during this period, the center was a maturing institution, for better or worse. Regular funding was in place, and I don't know if the current people noticed it, but we've had 50 years of continuous funding from NSF. I worked at NSF for 3 years, and I do not believe any other institution has had 50 years of continuous funding. NASA, occasionally DOE and NIH. Randy talked about the building of Beta Hall. This was before I started coming to the center, but one thing I learned was that the physicists actually co-signed a loan, a bunch of them, but there was only one signature on the loan co-sign that counted. I'll let you guess whose that was. In 1980, I think serious bicycling began. Not just bicycling around the town. Fishbane and myself were awed by Greg LeMond, and some people in the room might remember the 1989 Tour de France that LeMond won on the final day, coming behind a time trial. They don't do that anymore because they don't like surprises. Our first audit from NSF, we were barely beyond the cigar box. I was the assistant treasurer. The federal government sent Steve Taylor, a name that's familiar to many because he is now our financial firm. But he was sent by NSF, and he showed up in a suit and tie, so not just a suit, but a tie, and couldn't figure out what the hell was going on here. After a few days, and I think one of the things that really helped was a party that Sally had at her house where a National Academy sponsored exchange of Soviet scientists came, and they realized this is like a really important place. They may not know how to do bookkeeping, but they're doing really important work. And Steve Taylor explained to me that we had misspent, I don't know, a couple of $100,000, but we just miscategorized it. Our housing losses could be counted as participant support, and at the end of the day, we had misspent $25,000, and if we wrote a letter to NSF saying that, they would forgive us, and they did. And then we hired Steve Taylor to set up our modern accounting system. Tragedy struck in 1988. Heinz Pagels, who was a trustee, died on a hiking accident. And we honor him with our public lecture series that's dedicated to his memory. The modern governance, and it really is modern governance, came into play in 1989 in an odd collaboration of Randy, myself, and I don't see Mike Simmons. Remember my picture from 1980? I was not exactly the establishment. And what's remarkable is I've been involved with a number of organizations recently that have revised their governance, and it looks just like ours. It really is modern, and it works. And we were noticed. In 1990, I got a call in Chicago, I was president, from Margaret Thatcher's people. She wanted to visit us. At least that's what I thought they were saying. But what they were saying is if we invited her to visit, she would say yes, because she doesn't, it doesn't work that way with famous people. They don't ask to visit. You invite them and they say yes. She visited. I arranged for short presentations by physicists. It turns out that's an oxymoron. And Sally, it almost canceled the formal tea that Sally had set up. But Margaret Thatcher had such good manners that she stayed overtime for that tea. And you remember that was a summer that she and George Bush met up in Aspen, and well, we think George Bush was here. There's no evidence that he was here. People know that story, the limousine and all that. Oops, what did I do? Oh, I blanked it. Okay, let's move on. Completing the campus. We existed on land that we didn't own. It was owned by R.O. Anderson, and he sold it in 1979 to somebody named Hans Kontrup. And I love this story because the absolute value of his wealth was always known. It was billions, but it was the sign that was indeterminate. And they did a sign check, and it was negative. He went bankrupt. And I think this is a true story. Donald Trump wanted to buy the land. But one of his proteges, named Mohammed Hadid, swooped in and bought the land. And we were in a bit of a query because we thought we actually owned buildings, and you can't own a building if you don't own the land. It's something I learned. And so there was a long period of time where the president's duty was to go to city council meetings. And my mantra was, all we want is our circle of serenity. And that was Peter Kaus's invention. And it really, I see John Bennett smiling. Everyone got it. And of course, George played a major role. I showed Jeremy Bernstein was our ears on the ground because he lived here almost full time. And in the end, 3.5 acres were deeded to the Aspen Center for Physics, which is our campus. From 93 to 96, with land in hand, David Schramm, my mentor, here's an early picture of him around the time he first visited the center, led the design of a replacement for the Hilbert Hall that Randy talked about, and also led the $3 million fundraising. And that resulted in the, one of the buildings you're sitting in here. And let's see, so Tom Applequist was president. Harry Teague was brilliant. He came and, we explained to him what we wanted, and he listened. And then he produced a plan that was much better than what we wanted. And he created a fantastic smart hall and the campus that we have. In 1996, just as the building was being completed, we hired our second administrative vice president after a grueling thesis defense. If you read her history of being hired, I don't know how many interviews there were, and she would have been better, defending a physics paper than, anyway, here's a picture of Jane. Who else? Did I miss anyone here? Oh, Bill Frazier was the client's representative during the building, and that was absolutely crucial. And someone is sitting in the red chair over there, which I forget the story of the joke, but anyway, that's the Bill Frazier chair. And Bill kept us on budget, on schedule, and I should mention Shaw Construction. They did it. They did a great job. Here is the map of the meadows. Here's the Roaring Fork. What you can see here is the Circle of Serenity. And what you can see is Hilbert Hall, you can see Beta, you can see Stranahan. And what Harry said is, that's a really pretty view there. Don't put the new building there, put it here, and it creates a campus. And we said, no, Harry, we just want the building right. We didn't say that. And so he created a beautiful campus, and here are some pictures of the buildings. We could not have done this without the help and support of friends in Aspen. And I don't have enough names up here, I'm sure. The late Marty Flug, the Smart Family Foundation, that was Doug Stone's family, Larry and Susan Marks, Michael Fain and Judith Barnard, Nick and Maggie DeWolf, and many, many others. But the big surprise here is, believe it or not, physicists actually made donations, and I don't know what the sum total was, but it would impress physicists. It would not impress other people, but okay, let's talk about the science. So the foundational science, the first science here was particle physics, and the magnet was MGM, Murray Gell-Mann. Who wouldn't want to come spend 2 weeks in Aspen with Murray Gell-Mann? Well, I see someone laughing, but and he was the magnet. But over the years, there were other very important people. Sidney Coleman, the great Harvard field theorist, used to spend every other summer here and shape the program. Pierre Ramon, who is a president, Dick Slansky. And I just mentioned two of these big achievements. One is string theory. So in 1974, string theory was declared dead. But the center, Murray, thought, there's something there. It's really interesting. And there were a small group of people, Michael Green, John Schwartz, Lars Brink, who had come to Aspen. And they made an important discovery in 1984. And this is where modern string theory began. This is called the first string theory revolution. And it happened here in Aspen. And it changed the course of physics. The other changing the course of the physics, during COVID, people probably heard about, there's this new paper about COVID, but it's a preprint on the archive. And many people heard those two terms. The archive was invented here by a chance encounter between Paul Ginsberg, who I think is here, and Joanne Cohen. Joanne was a graduate student, and when the latest string theory paper came out, she collected it. She had a mailing list. She then mailed it to all the people who were interested in the paper so they could see it as soon as possible. They met on a bench in Aspen, and Paul Ginsberg said, there's a better way to do that. And 1991, I can't do the addition, but 30-some years later, the archive has truly transformed how science is done.
You didn't mention that Michael Green told me in 1984 that he learned the differential forms from my lecture notes.
Oh, okay. I should have mentioned that, Paul. Okay. The second pillar here was condensed matter physics, and the magnet was Phil Anderson. And Phil Anderson wrote a very important paper that was more is different. At the time he wrote that paper, the field of condensed matter physics was called solid state physics by most people, and by Murray it was called squalid state physics. And Phil had the vision that there was incredibly exciting science there, and he was right. And Aspen is where that transformation took place. Phil, of course, played a major role, but also Elihu Abrahams, David Pines, and Gordon Baim. But this was really ground central for, or the mother church for Phil Anderson condensed matter physics. And I was very fortunate. I never took a solid state physics course as a graduate student. So all the condensed matter physics I know, I learned here. And so I learned modern. Astrophysics, that was the third one to come into play. And it all started with neutron stars. And the physicists, the neutron stars were discovered in 1967. The pulsars, the little green men, some of you may know that story by Jocelyn Bell. But the physicists thought neutron stars were far too important to be left to the astronomers. And so they started working on them. In 1972, from 1972, there was a 1-week non-Aspen style NASA-sponsored workshop. So it was, dawn to dusk talks, but it got astrophysics started. Some of the people involved, again, David Schramm not only played an important role in shaping the buildings that we see, but also in getting astrophysics going here. Sterling Colgate, such a great picture of him, Dave DeYoung, who was also a president, Craig Wheeler, and Gordon Baim. I don't know any other physicist with broader interests. Am I getting near the end? Okay, I'll try to hurry up here a little bit. We mainstreamed astrophysics in 1990, and it became the third pillar. I'll skip this part, you can read this. But this is really fun. I saw this in a report this year that summer workshops in the last decade, 48 for astrophysics, condensed matter 27, elementary particle physics 34. So let's see. So this Aspen brought together particle physics and cosmology. This was one of the early workshops. There's David Schramm. That's me in the back misbehaving. Katie Fries, Alan Guth is probably someone you've heard of, Paul Steinhardt. And you've probably heard about the acceleration of the expansion of the universe, discovered by two teams. And one of the teams, led by Brian Schmidt with Adam Rees, they would come here every summer. This is a picture of them on the patio. And so they would plan their strategy for the next year. There were other scientific activities. The first winter meeting was in 1985, and that would not have happened without Marty Block and his wife, Bea. And I noticed that in 2023, there will be 8 weeks of winter meetings. Stephen Hawking, some people may wonder what this old wooden thing is here, this ramp. I believe that this is the original ramp that we constructed for Stephen's wheelchair, because in the 90s, Stephen came here. He gave the biggest physics public lecture here at the Music Tent in 1995. Marty and Bea's son, Steve Block, is active in the biophysics program. And I'll just end with this. In 1994, we had a focus week on women in physics. And at that time, there were only a couple of women who came to the center, partly because there were not so many women theoretical physicists. And so these three organizers, Catherine Callan, Liz Simmons, who's now the provost at UC San Diego, and Katie Fries, organized this. 25 of the 80 or so participants were women. And you might say, 1/3, whatever. We had never had that kind of mix before. And it made the culture of physics, the concept, concrete, both to the men and the women. It was really transformational. Bernice was not an organizer, but she certainly was an inspirer, and I list the statistics here today. Thank you.
Is Rosie Wyse, alumni centennial professor at Johns Hopkins University, and she was the president of the center from 2010 to 13, and is honorary trustee. So please.
Well, it's certainly a great pleasure to be here, and it's wonderful to see everybody here. My task was really to talk about shall we say, late middle age of the Aspen Center for Physics. Mike has told us of all the early years, all the vibrant things that were happening to get more or less the center that we have today. And that didn't work. That does work. So we've just heard that really the bedrock of the Aspen Center for Physics is the summer program. The topics of the workshop, they're selected by physicists really to be the cutting edge of what's happening in the physics world. We've heard that there were 3 cores really that had been developed: astrophysics, high energy physics, condensed matter physics. Over the years from 2000 to 2015, these evolved. We've already heard from Michael that indeed we started to include the physical processes that are manifest in biological systems. So biology as done by physicists is one of the ways of putting it. Even in, decades ago, scientists knew we should be really concerned about the climate change. Happily, the politicians are realizing they need to do something now. But even back then, we were organizing workshops here on climate physics. What's happening? What can we do about it? And also, moving more into policy, having discussions about energy policy, the physics of energy. That's all related to, of course, to climate modeling. So broadening, but always having an eye on what's cutting edge physics, what are the things that Aspen can do that might not be done elsewhere, that we can really bring the best minds together to work on it. Over this time, with all these activities going on, the summer season expanded a little bit to 16 weeks. So from late May to mid-September is when we have physicists coming here. And of course, we don't just do physics. We've heard about hiking and biking. The other big advantage of Aspen in the summer is the music festival in school. You may have noticed a grand piano in the corner, which we have courtesy of the music festival in school, and largely due to the efforts of Andre Ruckenstein, who was president in the mid-2000s. He instituted Monday piano music. So every Monday afternoon here, we gather, the public comes in as well, and we have some beautiful piano music played by students at the school. And it's a really wonderful event on Mondays. Again, Andre Ruckenstein was very active in organizing that. Physics is an international endeavor. We heard people acting askance at foreign accents when there were physicists in town. But more and more international teams, we really wanted to get everybody able to come here, even if they came from a country where funding for their research really didn't allow them to pay to come over here. So we were really happy in 2003. We got a grant from the Simons Foundation, which was specifically to cover the costs of exceptional scientists from developing countries. And this has really increased the diversity of the community here. Increased diversity, increased breadth of ideas. It's been wonderful. Also, on the diversity angle, we've heard about women increasing participation by women physicists. One of the really wonderful aspects of the contributions of women and gatherings of women in the Aspen Center for Physics are the informal lunches that Bernice Durand started. She started them on an ad hoc basis earlier, but starting in 2008, she made it a weekly activity. the women physicists who were present and who wanted to join for lunch, we would wander over to the Durand's house, just a 5-minute walk away. Randy was banned after he set the table for us, and we would gather there on their patio and have a really joyful discussion. We were not allowed to say, oh, it's horrible being the only woman in the faculty. No, we were there to share ideas, share positive things about our career, find mentors, find mentees, enjoy discussing physics with each other, etc. It really was wonderful, and this tradition continues today, sadly without Bernice, but actually 11 of us went for lunch last Thursday. There's usually about 10 women get together and we wander to a local restaurant. It's a really nice tradition. Although this is the 60th, my remit includes a very special summer, so I thought I'd say a few words about that, particularly George's contributions. That summer was 2012. I think we can still all do that level of arithmetic at altitude. So 2012 was the 50th anniversary, but it was also a very special summer for physics at large, and that was to do with the Higgs boson. So we've been discussing summer workshops. Well, how do they happen? The Physics Center is supported by volunteer physicists. They form committees. They solicit proposals for what should happen next summer. And so they selected, in summer 2011, there were 2 workshops that were selected. And the titles, well, there were more than 2, but 2 high energy ones that were selected said, the Large Hadron Collider shows the way, and the other one said, new physics at the Large Hadron Collider. And the abstract of the second one said, ... a standard model Higgs will have been discovered or disproven. So that was in 2011. And of course, in 2012, it was the first part of that statement from the abstract that had happened. The Higgs boson, July 4th, 2012. This is the press release of the crowd of physicists at CERN. And so it was very prescient. Well, because we're all physicists, we could see that this was very likely to happen. But it was a really great summer here at the Aspen Center for Physics. And what about the 50th anniversary? I was the president at the time, and we had events through July and August. I would like to thank Michael Turner, who was the chair of the board, and John Bagger, who was chair of a committee I set up, the 50th Celebration Committee. John is now the CEO of the American Physics Society. And the indefatigable, I can't say it, I can spell it, but I can't say it, the untiring staff, which we've had already introduced, Jane Kelly, but also Paula Johnson and Patty Fox. What did we have? We had the July 4th parade, in which the Physics Center had a float, sort of mimicking a previous parade. But due to time zones, we were able to celebrate the Higgs as well at the parade. And we had a formal ceremony with dignitaries such as the Aspen mayor. It wasn't John at the time, it was Mike Ireland. And the head of the National Science Foundation. You've already heard we've had continuous support from the National Science Foundation. We've also heard there have been glitches along the way, but it's wonderful. They've continued to fund the Physics Center. It was really good to get the complete head of the National Science Foundation here. One of the really nice events was the recognition of the Physics Center as a historic physics site. really acknowledging the vision of the founders, George, etc. And here's just a picture. If you haven't seen the plaque, this is Michael Turner, me, and Bob Byer, the APS president, presenting the plaque. It's on the wall just at the entrance to Smart Hall. So if you haven't noticed it, here it is. Let me highlight George, of course, because it starts with acknowledging the founders of the Physics Center. And this is a picture I took of it. It's shiny black granite, but I thought it looked rather nice with the beautiful campus reflected in it, the trees and the light. So if you might want to have a look later if you haven't noticed it. And here's a picture of us having a celebration with George and Michael Cohen. I would just notice there was an earlier Founder and Pillars weekend in 2006, and all the histories are on the Center for Physics webpage for you to look at. Strong support that the Physics Center has from the Aspen community is something that's extremely important to us. And Michael already mentioned the winter public lecture series named after Heinz Pagels, which is supported by the Nick and Maggie DeWolf Foundation. But we did special things during the 50th, and of course we're having this special celebration today for the 60th. I would just notice one of the special things we did during the 50th was a talk by George about his photography collection. That was in collaboration with the Aspen Institute, which is another important aspect of life at the Physics Center. We do have occasional collaborations, and when they happen, they're really good, like this one. So I just have this picture of George with a camera. It was really nice. The exhibition of highlights from his collection was up for about a month, and beautiful photographs and a very stimulating talk. I'll just finish with a little bit about what was happening with the winter conferences. So we've heard they were started by Marty Block, and these are very different from the summer programs. The summer is workshops. You spend a lot of time talking in the halls, not too many formal talks. In the winter, much more intense. Lots of short talks in the morning and in the evening. In the afternoon, you're free to, well, do whatever you do in Aspen in the winter. Lots of discussions on the chairlifts, etc. Again, unlike the summer program, graduate students can come to winter. And this really is a wonderful opportunity for them to come, find out a little bit about what happens in Aspen in these short, intensive talks. They can show their own work. They can get feedback from all the more senior people there. And these conferences are really popular. Over the 2000s, they increased from 5 a year to about 7 to 8 a year, and as Michael already commented, now they're 8 a year, and these are really enjoyable. Michael mentioned the blocks again, starting them in honor of their 80th birthday. Marty and B. Block, Stephen Block and the other children made an endowment so that the other nice event, I didn't put it here, at the winter conferences is that one of the young people present is given the Block Award for Best Talk. And that's a lovely ceremony too. It used to be, of course, the Blocks would be there and they would make the presentation themselves. But again, this is really the opportunity for early career physicists to come and enjoy the center. And now I'll turn over to
Frieman, who is a professor at the University of Chicago, will tell us about the present of the center. He was the president of the Aspen Center until this summer, and no sooner he stepped down, the University of Chicago snapped him for leadership position, and now he's the chair of the Department of Astronomy and Astrophysics. So Josh, please.
Historical, chronological view and do something a bit different. But I do want to just, since there's been talk about the fantastic staff that we have here at the center, I do just want to recognize, so Mike talked about Sally Mensimer, we heard about Jane Kelly, tremendous leaders, administrative vice presidents of the center. I just want to acknowledge that 4 years ago, we made our latest transition to our current staff, led by Amanda Jenkins, and they're fantastic. So let's give them a round of applause. So when George passed away last May, John Bennett contacted me about composing an op-ed for, okay, I have to say it, for the former paper of record of the city, sorry, for the Aspen Times. And he and Judy Schramm helped me write it. And I gave them no credit, co-authorship credit whatsoever. But from them both, I learned how remarkably multifaceted George was. He had so many sides that he was effectively spherical. Every time I would make a list of George's accomplishments, they would say, no, wait, there's one more that you forgot. So, the ones I have is physicist, photographer, philanthropist. They don't all start with PH. Educator, community activist, rancher, restaurateur, entrepreneur, and I'm sure there's a bunch more that we've probably left off. But as we've heard from Randy, George first came to Aspen to, as we say, do physics. I always think, we don't talk about doctors doing medicine, really, but anyway. And he had this crucial realization that Randy mentioned, that I cannot do physics alone. I must have someone to talk to. And that epiphany led to this place. Through this creation, I just want to acknowledge that George and his co-founders have profoundly impacted the careers and lives of well over 10,000 scientists from around the world. And I think that's quite remarkable. Many of us have met those who became longtime collaborators, future colleagues and mentors, and lifelong friends here at the center. But while today we're celebrating the center and George's legacy, I want to talk briefly about 3 existential challenges that I think the center is facing: diversity, inclusion, and housing affordability. Very, very exciting topics. And my thesis is that these are inextricably intertwined. If we can't make participation in the center more affordable and inclusive, we will not be able to make it more diverse. And if we can't make it more diverse and inclusive, it won't be worth making it more affordable. So I just want to talk about these three items in turn. So this is sort of the downer part of the session, and then Risa is going to end on a high note, I promise you. So first of all, diversity. So we heard a bit about this from Michael and Rosie, and indeed the center has made, I think, really tremendous strides in diversity. Last week, the center hosted this remembrance and celebration of the life of Bernice Durand, who you've heard about repeatedly. Bernice became the first female member of the center in 1980, only 18 years after the center's founding. Okay, that was great. And the center now has 25 times more female members than it had at that time. And about twice the number of female members that we had just a dozen years ago in 2010. So I think that's significant progress. And in the last few years, we've made concerted efforts to increase the number of members from groups traditionally underrepresented in physics, including women, but other groups as well. And we've also, in recent years, been able to increase the diversity not only of our membership, but of our summer workshop participants through improvements to our admissions process and through increased and more transparent financial support for those, again, from groups that have traditionally faced barriers to participation. And that, again, has paid off in a significant jump in summer participation from underrepresented groups just in the last 2 years, including a 25% increase in the fraction of women participants over this period. So that's great, and that's real progress. But we still have a very long way to go. And the road to greater diversity, as we found, is not smooth and monotonic. It has bumps, dips, and potholes that make it quite difficult. And that leads to my second topic, which is inclusion. I think we've learned the hard way, certainly I have, that good intentions about diversity are not enough. Just as physics is complex and requires expertise to master, so too diversity and inclusion are complex topics that require expertise and experience to understand. Now, you may be surprised to hear this, but physicists are not known for their humility. They often suffer from hubris, which the ancient Greeks considered a tragic flaw. The physicist's hubris is, of course, that since we understand physics, by extension, we can understand everything about the world from first principles. For the Greeks, hubris was dangerous. It led to murder, wars, catastrophe. Physics hubris is usually not dangerous, it's just really, really annoying. But in the case, and look, we all know those people, right? Present company accepted, I'm sure. But in the case of diversity and inclusion, that kind of hubris is a real impediment. So to make further progress at the center, we need to marry continued increases in diversity with collective introspection and dialogue about inclusion. That is about the center's culture and how to make it more broadly welcoming. Going to the next level is really going to require us to work harder and deeper, and to have a willingness to listen to an array of voices, including those with greater expertise on these topics than most of us have, and certainly than I have. And so I'm really very happy that the new leadership of the center is already engaging in and fostering such discussion. I think it's really important. But this culture change is going to require both internal conversation within the center and more effective outreach to the broader scientific community. We've heard about the centers, we have this cadre of 75 volunteer members who all work incredibly hard to serve the roughly 1,000 physicists who come to the center annually during the summer and winter. And that's terrific. But outside the center, from the outside, the center is still often perceived as an exclusive club of members. And this perception is clearly a barrier to fostering a greater sense of inclusivity. Now, there are excellent reasons. We heard from Michael and Rosie about kind of changes in the way the center operates and putting it on a more sound footing. And the center does operate tremendously well with this cadre of volunteers. But the effectiveness of our modus operandi doesn't obviate the need to examine them and to explore how to make them more inclusive and more transparent to the world. So my dream for the center is that it becomes a major change agent for diversity and inclusion for the entire physics community and even the larger scientific community. A place where people of diverse backgrounds come together to have their scientific careers boosted and invigorated in this really special place. But I don't think we can reach that promised land with good intentions alone. We need to do some intentional house cleaning, and I'm glad to see that it's starting. Okay, last topic. Speaking of house cleaning, let's talk about houses. The other major impediment to growing diversity is the disappearance of affordable rental housing in Aspen. It's something everyone's aware of. I've been coming to Aspen for almost 40 years. Ever since I've been coming to Aspen, it's been ridiculously expensive. but the pandemic migration of the last 2 years has poured tanker trucks of fuel on the wildfire of spiraling housing costs. The center's been fortunate to have this major support from the National Science Foundation that we've heard about. And we just heard that our 5-year grant for the next 5 years has been accepted. That's tremendous. And that enables us to partially subsidize housing for our participants. But that support is pretty flat. And as you can read in the newspaper, housing costs here are doubling on a few-year time scale, in some cases even less. And already we know that some physicists are declining to come to Aspen because it's too expensive for them to do so, even with the subsidized housing, even for those with research grants. And if these costs continue to rise, our community will simply be priced out, starting with those who face the greatest barriers, those earlier in their careers, those with family responsibilities and associated costs, and those from underrepresented groups and institutions. If we can't solve this problem, the center is going to become less and less diverse, and then it's going to disappear. So this problem, of course, isn't unique to the center. All nonprofits, and in fact, most for-profits in the Roaring Fork Valley are facing this problem. But it's gotten to the point where some of our members are now asking whether we should pack up and try to move the center somewhere more affordable. I know I suffer from a lack of imagination, but I can't envision the center existing anywhere else. Setting aside the practicalities of such a move, the identity, the spirit, and in my view, the success of the center are inextricably linked with its location. This is our home, and we want to preserve it. Fortunately, the members and leaders of the center are thinking hard about this problem and exploring a variety of approaches to solving it. For example, this summer we're housing 25% of our participants in Snowmass Village, an experiment that will likely continue. We've also been seeking ways to increase financial support for participants who need it most. We now have a nice grant from the Sloan Foundation. We heard about funding from the Simons Foundation. We're exploring other avenues. And there are additional approaches it would be premature to talk about here, but it's likely that a long-term solution is going to require financial resources beyond those that the center currently has. So you've been warned. Okay, so I want to end on a high note. I've focused on the challenges currently facing the center, and it's because they're important, but the center is strong, and I'm confident that the center's membership and leaders engaging with the broader community will find creative and sustainable solutions that will make it even stronger and more vibrant in the future. What we have here is so unique, precious, and important, with so many people who care passionately about it, that I'm sure it's going to survive and thrive. So I just want to end by saying thank you to George, and thanks to all my colleagues who have made this the remarkable place it is. Thanks.
Thank you, Josh. I just wanted to point out that Josh and the team led by Amanda Jenkins navigated us through the very challenging time of the last 2 years during the pandemic. And the last summer, we had a very successful summer program. And that was actually one of the first major in-person activity in physics. And many young physicists, in particular the postdoc, told us later how much they appreciate the opportunity that the center provided. So I'd like to take this opportunity to thank Josh and the team for their wonderful effort and the leadership. So the last speaker is Risa Wechsler. She's a professor and the director of the Kavli Institute for Particle, and I guess I'm missing something, at Stanford. past particle astrophysics, excuse me, thank you, at Stanford University. And she's currently a trustee of the Aspen Center for Physics. And she will tell us about our future.
Okay. It's a great pleasure to be here and an honor to be here celebrating the Center's 60th anniversary. We've heard some great things about history and also about the contributions of George Stranahan this afternoon. And although I did not have the pleasure of knowing him, my own career in physics was very clearly influenced by him through my participation in the center. And I've really enjoyed learning about his life and his passion, and especially his incredible energy for community building, which I think is at the heart of what the center does. So you've heard already from a couple of speakers about this core idea that you cannot do physics alone. You need someone to talk to. And this is from his obituary in the New York Times last summer. That's really as relevant today as it was for George and his peers, and really at the heart of what I think the center is about. So I was really lucky to spend time at Aspen each summer in my first few years as a postdoc. That was starting 20 years ago. I think I was the same age at that time as George was when he had this discovery. You know, it really was just a fantastic environment. We had a wonderful group of young people here. All our talks were on blackboards, as they are now, tons of discussion. We worked hard. We also spent time outdoors, and I'm going to show you these embarrassing pictures of myself. From whitewater rafting, the top of Electric Pass, still my favorite hike in Aspen. And really, we learned a lot of physics from each other, and as what my colleague Andreas Berlin said yesterday, that's really where we built our community of peers. This was a really exciting time in my subfield. I'm an astrophysicist, cosmologist. At this time, the first large galaxy surveys were coming online. And at the same time, we had cosmological simulations, which were being higher and higher resolution. And for the first time, we're able to resolve the substructures that hosted galaxies. And based on these advances, we were really able to start articulating in much more detail how galaxy formation and structure formation are intertwined, and how this connection really drives how galaxies form, and also is at the heart of our ability to use galaxies as probes of fundamental physics. So to just give one example, these three people here, including myself, wrote a paper which was based on 3 weeks at Aspen, a very intense summer. I was shocked, actually, to realize we submitted this paper 2 months after leaving. We were here in June, worked very hard to submit that paper, which really, in some ways, laid out the essential elements that underpin our understanding of the statistical connection between galaxies and the dark matter halos that they live in. And for several summers around that time, there were several of us who worked those things out, and that led many, many years later, just a few years ago, to this review article that I wrote. And I mention this just because those summers were so essential to my own development as a physicist, and also to developing a community of people who defined this particular subfield. And I know that's true for so many of us here, so many physicists in their own subfields, that the communities were built here and developed over time, really through people that we got to know at Aspen. So I think that's really the core function of the Aspen Center for Physics, bringing people together to learn from each other in a beautiful environment that really does minimize distractions and creates the conditions for deeper thinking and collaboration. And that's really still at the heart of what makes it a special place. I was here at a workshop earlier this summer where many people for the first time, I think we're seeing colleagues from around the world for the first time in 3 years after just being stuck in their computer boxes. And I have to say that the energy was just palpable. Right? People talking with each other about new ideas. It's what makes physics vibrant and exciting, and Aspen is really the best place in the world I know of to do this because of the center. So I watched this great video of George Stranahan and his induction to the Hall of Fame, and I just loved this quote: "Man, I want horizons, I don't want boundaries." So I was asked to talk about the future, and so I'm starting with this quote, and I just love this quote, and I want to talk about how we make sure that in the future the Aspen Center for Physics plays a key role in broadening our horizons and breaking down boundaries. So first, let me just say that I am personally incredibly excited about the physics opportunities that we have in the coming decade. So in my own field, the last 2 decades since I've been coming to Aspen have been transformative and just full of discovery after discovery. We've learned a lot about the physics of galaxy formation. We've learned about how dark energy controls the expansion history of the universe. We've learned about how dark matter is really the core thing that drives structure formation. We've learned new ways of observing black holes and how they teach us about gravity. We've discovered thousands of extrasolar planets, and they have totally overturned our understanding of how solar systems formed. But I think the next 2 decades are going to be even more exciting in my field and probably in physics as a whole. In my field, the new observatories that are coming online, some of you may have seen the pictures a few weeks ago from JWST, but that's one of many new observatories coming online this decade. And we're just guaranteed significant new surprises. And what we need when we have surprises is we need ways to bring people together and get new ideas. So I hear similar excitement from other areas of physics. During just my few weeks here this summer, we have physicists who are working on new ideas for high temperature superconductivity, for manipulating atoms, thinking about new ways that machine learning and effective field theories can help drive discovery in particle physics. And I also think that some of the most exciting opportunities for the coming decades are those that cross disciplinary boundaries. And really, in modern physics, many of the most fundamental problems now really, I think, require interdisciplinary work. And I'll just give one example from my own field, but it's really one example. And I'm particularly interested in learning what dark matter is. It makes up most of the mass in the universe. We have measured really precisely its density in space and even made maps of where it is. And we've explained how it's essential for the formation of galaxies, but we don't know what particle it is or even whether it's a sea of particles. And for most of the last 20 years, we've been looking for it really hard and looking in a fairly narrow range, just a few orders of magnitude in mass of what the dark matter particle might be. But I think based on our current understanding, there's maybe as many as 90 orders of magnitude in mass that the dark matter particle could be. So how do we make progress on a really difficult problem like that? Well, what's most exciting to me is that there are a bunch of new ways to study it. And they come from really different fields, and many times fields that haven't worked on this particular physics problem before. So particle physicists who care a lot about what this particle might be, it's a clear indication of a deviation, something that's broken with their theories, but they're coming up with new ideas of what the most likely possibilities are and new ways that we might see the interactions. Astronomers are also finding new ways to actually probe not just where the dark matter is, but also its potential interactions over that whole range of parameter space. But the other thing is that there's whole new fields of physics, including condensed matter and AMO and precision measurement and quantum sensing that actually have new ways to look for dark matter. And I think these synergies are what make this a particularly interesting problem to me, but also have applications in many, many other areas of physics. Because this means that people who don't usually read each other's papers or attend the same conferences, they really need to learn from each other for us to make progress. And this is not easy, but Aspen is a fantastic environment for this kind of cross-disciplinary engagement. And I think we should lean much more into this in the coming decade to really make Aspen the best place for physicists who want to come learn from each other across these boundaries. Modern physics is also very international, and I think Aspen should have at its core, even more than we do now, the goal to bring people from all over the world together. International collaboration is really required in order to make progress on some of the big problems that we have in physics. Lots of big projects in particle physics and astrophysics are just not possible without international collaboration. And this kind of collaboration has been better enabled in our new Zoom-focused world, But there's really no substitute for working together at a blackboard to understand something, or for the long physics discussion you can have on a hike up the mountain. And I really think we should embrace the opportunity to make Aspen Center for Physics really the best place in the world for people to come together and learn in this way, including physicists from countries that have generally been underrepresented in science. Okay, one more quote from George. What you do in science is challenge assumptions. And I think George really articulated that this is really at the core of the scientific enterprise. Now, physicists have a special knack for this and a pride, we already heard from Josh about their hubris, in doing it well. I think we need to take that attitude beyond our physics. And we need to take it to continue to challenge the assumptions about how best to build an inclusive community and enable the best generation. You know, to be honest, most of my career when I have come to history of physics events and have seen the history of physics celebrated, I've honestly found it pretty alienating. And I love the stories of discovery, of the way new insights and new experimental windows can lead to dramatic changes in the way we understand our world. But as a young physicist, I had a hard time recognizing myself in those stories. And I see that for many young physicists now. The ACP was certainly initially built for a different time, when the demands of one's work were different, and the people doing physics were a much more homogeneous group, as you can see from the pictures we saw there, than they are now, and I think especially than they need to be in the future in order for us to maintain our vibrancy as an intellectual enterprise. So we really need to be much more deliberate and intentional about how we enable people from all backgrounds and identities to have the luxury that we have here of community and the intellectual environment that has been built here. You heard from some of the past speakers that there has been significant progress. Certainly there are more women participants in Aspen programs and in the leadership of the center than ever. But this progress really has been intermittent. I think it's been quite heterogeneous across subfields, and overall just much too slow. I think we have an especially long way to go as a community in inviting and enabling people from racial and ethnic minorities and people from developing countries to really be full participants in the global physics community. So in order to get there, physicists really have to challenge their own assumptions about the ways we do things to make this happen, and to come to the problem with curiosity and the learning mindset that we bring to our physics. And to really look to change the way things are done in physics to better attract and enable the most talented scientists from all backgrounds to contribute at the very highest levels of discovery. This is really essential, I think. It has to happen for us to remain vibrant and relevant. And I share Josh's vision that the Aspen Center for Physics should not just be a participant in this enterprise, but should be a leader in the physics community and in the global scientific community. I think, as Josh also mentioned, the specific environment of Aspen, of the Aspen community and of the rising cost of living here may make this even more challenging than it has been in the past. But at the same time, I've seen incredible creativity and also commitment by engaged physicists that really care deeply about the center's future. So I believe if we really lean into the values that George Stranahan laid down at Aspen's founding, building collaborations, expanding horizons, and really challenging assumptions, including our own, that we can really turn this existential issue into an opportunity and to enable the Aspen Center for Physics to be a leader in how the physics community evolves and to help it become an even more vibrant place to spark discovery. Thank you.
Thank you, Risa, for the very inspiring talk. So that's the end of the formal program. So let's thank all the speakers. I'm afraid we went way ahead out over time. So I think we have some reception prepared outside. So please go there, and then we can talk more as physicists would do. Thank you.